Page 3, folks. Let's get after it. Okay, so, oh, yeah, so here on page 3, there's, it's asking you, or I am asking you, to go back to your textbook onto page 729 and read a little bit about special case products, okay? Here's the gist of what the special case products say. It's all about situations where you've got this, a binomial squared, or when you have this other situation called a conjugate, a binomial conjugate. So first off here, don't forget, a plus b in parentheses to the second power is not a squared plus b squared. It is not. It's this. Right? And if you box method it or FOIL it or whatever, what you end up with is a squared plus 2ab plus b squared. I'm not going to say too much about that because I know we've talked about this before. This is kind of just a reminder of that rule, right? The other situation, the other special case, is this thing called a binomial conjugate, which is a situation where you've got two terms, but in the second binomial, the second term is the opposite of the second term in the first one. If you FOIL this out, you multiply it out, okay, you end up with this. A squared minus b squared. You don't believe me? Put it in the box method and try it. And this is what you'll find. Now the other thing you might be thinking is like, wait, that's a difference of squares. And you are correct. So this is another way of thinking about why is the rule for a difference of squares this? When you're factoring this, you do get this, if you think back to chapter 7 or whatever chapter that was. Okay, so that's special products. Now, some examples with this. Example 6, no, this is example 5. Square root of d plus 3 in parentheses to the second power. So I'm not going to box method this one. I'm just going to kind of talk it through. I'm going to have the first term times this. So actually, I'll go do this. Square root of d plus 3 times the square root of d plus 3. Okay, I'll do that. Square root of d times square root of d equals d. Square root of d times 3 is 3 times the square root of d. This one, 3 times the square root of d, is another 3 times the square root of d. And then for the last, 3 times 3 is 9. Okay? Combine like terms, you get d plus 6 times the square root of d plus 9. Yep. Yeah. Okay. Same deal here, right? I've got 5 times the square root of y minus the square root of 2 times 5 times the square root of y minus the square root of 2. I hope you can see that. It was kind of careless at the end, but yes, I think you can tell what it is. This times this equals 25 times y, because what? Yeah, square root of y times square root of y is y. It's 5 times the square root of y times the square root of 2, but it's negative. It's going to be negative 10 times the square root of y. Same thing happens here. Negative 10 times the square root of y. And then negative square root of 2 times negative square root of 2 is positive 2. Okay. Combine the like terms, which are going to be the middle two terms, and you're going to get 25y minus 20 times the square root of y plus 2. Put a box around it because it's done. Fantastic. All right, example 6. Now we're going to look at these situations with binomial conjugates. So you'll notice these are opposites. Conjugate pair. Do you need to know that? Do you need to memorize that? No. You can always just throw it in the box method or FOIL it and you're going to get the correct answer. But if you can recognize that sort of special situation, you can save yourself some time because we know if it's like this, you're going to take the first term, you're going to take the second term, you're going to square them both, and then throw a subtraction sign between them. You could save yourself like 12 seconds, okay? think of what you'll do with all the time. So here, square the first term. The square, if I take square root of 3 times square root of 3, that's just 3. 2 times 2 is just 4. 2 squared is 4, but I'm subtracting them, so I get 3 minus 4. But 3 minus 4 is also known as -1. Sweet, right? There's one more of these. So it's like this. And you might be thinking to yourself, this one looks kind of like difficult AF as fraction. But it really can be much simpler if you recognize the pattern. Right? So it looks like this, and you're looking at it, and it's a mess of fractions and all kinds of stuff. But this is the same as this, and these are opposites. I can save myself this time maybe 15 seconds by recognizing this is a conjugate pair. I can square the first term, which is 1/9 s. 1/3 times 1/3 is 1/9. Square root of s times square root of s is s. Minus 3/4 to the second power is 9/16. Square root of t to the second power is t. These are not like terms, so that is a wrap. Page 4 is next.